In this problem, we want to synthesize this para-disubstituted benzene. We have an iodide and a carboxylic acid. And a couple of things to think about here. For this iodide, we don't have a direct electrophilic aromatic substitution reaction to put that on there, so we'll need to do this through the diazonium ion chemistry. And for the carboxylic acid, again, we don't have a direct method, but what we can do is we can put an alkyl group at this position and then oxidize. Okay, so what we'll start with is we'll start to work on this position by installing a nitrogen. Then we can direct the alkyl group, and then we'll do our functional group transformations. So let's start with benzene. And anytime we want to do this diazonium chemistry, we need to do the nitration. That'll give us a nitro group, and then we'll just go ahead and combine this with the reduction step to reduce that nitro to an NH2. And this time, let's use iron and hydrochloric acid as our reducing agent. Okay, so now we have this NH2 group installed, and we know that we need an alkyl group at this position, which will oxidize. And to do an alkyl group, we're going to do a Friedel-Crafts reaction. But never forget that there's no Friedel-Crafts with an amine. So what we need to do is we need to convert this to something that we can do a Friedel-Crafts reaction with. Also, since we do want para-selectivity, we don't want anything at the ortho positions, we want to get this turned into a bulky group that will block those two positions. So our best method for doing that is acetic anhydride, and we'll convert that to an amide. So now the nice thing about this amide is that it works fine with Friedel-Crafts. Also, since it's bulky, it blocks out those ortho positions, so we'll get selectivity at our para position. So now we can do a Friedel-Crafts alkylation. And really, you can install any alkyl chain at that position. It doesn't really matter, but we'll just keep it simple and use a methyl group. So we use methyl chloride and aluminum trichloride. That gives us our methyl group. From here, we need to get this amide converted to the diazonium ion and then to the iodide, and then we need to oxidize the methyl group. Let's go ahead and hold off on this oxidation, and first we'll deal with the nitrogen group. All right, so what we need to do is, in order to get this to the diazonium ion, we're going to have to take this amide down to the amine, and we'll just do a hydrolysis. That gives us the amine. Now we'll convert this amine to the diazonium ion, NaNO2, an acid. And then this diazonium ion, we can convert that to the iodide with potassium iodide. Okay, so we've carried this methyl group through these last few steps, and that's a good thing because the methyl group on this benzene ring is extremely stable, so it has no problem going through these steps. But now we need to finally deal with it and get it converted to the carboxylic acid. And we have a couple of conditions we can use to do this oxidation. You can do permanganate or chromic acid. Let's use the chromium conditions. So we'll use sodium dichromate and sulfuric acid, and of course we know these reagents just produce chromic acid as the active oxidizing agent. That oxidizes this methyl to the carboxylic acid, and we're done with the synthesis.